Okay, guys, in this lesson, we're going to look at a few more key features in a graph. So we've learned about domain and range. Let's look at a few more. Before we go on, let's look at some very common polynomial functions. This just means our graphs are continuous and there's no breaks and they have a smooth curve. So we have a linear function here. Our second example is a quadratic, it's U-shaped. Then we have a cubic. Then our fourth one is an exponential function that has that asymptote that we have talked about. We have an absolute value function and then a square root function. So we're going to look at different graphs of different functions and learn some more key features. So this would be a good time to pause the video and write this in your notes. Let me explain what it is. On the left column, we have the key features that we're going to be focusing on for this course. Then we have the definition of each of these key features. And then I put a third column of what I asked myself in order to identify those key features. So I'm not going to read through them all. So again, just pause the video, jot this in your notes. So let's look at our first example. We have a linear function. Here's its equation written in function notation. This is function f. And we're going to look at the domain first. So remember with domain, your focus is the x values. What x values are allowed in this function? So as we go left, we continue toward negative infinity. So this graph extends left forever. Then we ask how far right does our x values extend? And that is toward positive infinity. So all real numbers is our domain. Our range, we first ask how far down does this graph extend? The y values extend all the way toward negative infinity. And then we ask how far up does this graph extend? And it goes forever in the positive infinity. Then we want to know the x-intercept, and that's where it crosses the x-axis, and it's where our y value is 0. So we can see here that our x-intercept is a point. It's 1, 0. Then our y-intercept is when the x value is 0 because we don't go left or right. And so we have a y-intercept of 0, -2. Now let's talk about increasing. What we're asking is what x values cause this graph to go up? So again, we're just focusing on the x values that cause the graph to increase. And as we read the graph, we read left to right. So we are reading from left to right. So the x values that cause this graph to increase is from negative infinity to positive infinity. So this graph is continuously increasing. Now let's look to see what x values cause it to decrease. As we go left to right and we run along the line, we can see that this graph is never going to decrease. So that would be the empty set, or we can use the null symbol. In behavior just tells us what the graph looks like on the ends of the graph. So we are just concerned with this part of the graph. So we ask ourselves, as the x values decrease, as we go left toward negative infinity. So as x approaches negative infinity, that's just saying as we go left on the graph, as our x values decrease, what happens to the output? That's the end of the graph. As we go left on the graph, or as x decreases, the x values, the output values, f of x, also decreases in this case. It's going toward negative infinity. Then we have a second statement. As the x values increase, as we go toward positive infinity on the x-axis, as the x values increase, what happens to the output values? Well, they also increase. They are also going toward positive infinity. So f of x, my output, goes up. So as x approaches negative infinity, f of x approaches negative infinity. And then as x approaches positive infinity, f of x approaches positive infinity. So as we go left, our graph goes down. As we go right, the graph goes up. Now let's look at a second example. Let's look at the domain. What are the possible x values? So we can see that our graph continually is moving to the left, gradually to the left, so it can be negative infinity. And then our graph, it eventually keeps going to the right. It can go forever to the right. So we have all real numbers. Now the range, remember we always ask how far down does this graph go? And we're only concerned with our y values. So we're just looking at these y values here on the y-axis. So the range, how far down does it go? It goes down to right here at -4. So, and it is included because it's not an open circle. So the least value my output's going to be for this graph is -4, and then it continues to go and increase in the positive infinity. Here we're going to have two x-intercepts. So we have -1, 0, and we have 3, 0. Our y-intercept is going to be when x is 0, and it's 0, -3. Okay, on this graph, we have the left side is decreasing, okay, until we get, let's put this line, okay, the axis of symmetry we'll learn about later. So this vertical line splits my graph into two symmetrical parts. On the left side, it's decreasing. On the right side, it's increasing. And remember, when we're doing increasing and decreasing, we're only concerned with the x values. The x values is what causes my graph to either increase or decrease. And my x value at x equals 1 is where it changes from going down to going up. So the increasing is going to start when x is 1. And then it continues to increase all the way to positive infinity. So these are the x values. This range or this interval is what causes our graph to increase. Now, what causes the graph to decrease? And again, we're going from left to right, and we're just looking at the x value. So from negative infinity all the way up until when x is 1, my graph is decreasing. It's going down. So you notice that we will always use on a quadratic, we'll use our axis of symmetry when x is whatever, will be part of both of these intervals of increase or decrease. Notice I choose to use parentheses and I do not include the 1 because this value right here, it's neither the x part is neither going up or down, it's actually the turning point. So I choose to use parentheses. Some other folks may choose to use a bracket because it is not open. But for me, I'm going to use parentheses in this case. Our end behavior, so let's say as x approaches negative infinity, so always go left first, we're going to see what happens to the y. So as x decreases, as my x values decreases, what happens to the end? It's going toward positive infinity. So it approaches positive infinity. And then as x approaches positive infinity, f of x, so as the x values increase, the y values also increase. So you will notice on a quadratic, a parabola, the ends will always be the same. They'll either be going up or going down. Here we have a cubic function. And let's look at our domain. And as we, on the coordinate plane, we can see as we go left, our x values can be anything toward negative infinity. It continues forever. This will gradually be going left. And then as we move right, we will always be going right. And so that's all real numbers. So far you've noticed that the domain for each of our graphs has been all real numbers. And that will be true for most part, but there will be some cases where we will have something different. Now let's do the range. The range is all about your output values, and we're going to say how far down does this graph extend? And this graph extends, it keeps going toward negative infinity. And then how far up? So it has some turning points, but we're just seeing how far up it goes, and it's also moving toward positive infinity. Our x-intercepts, we have 1, 2, and 3. And so here we have, let's see, this hits, let's just estimate it. It looks as though it's negative 1.5, comma 0, and the origin. And we have, this one looks like it is 1.5, and it's okay just to approximate for right now, just when we're given a graph. So this has 3 x-intercepts, and then our y-intercept is the origin. Okay, let's talk about what values make this graph increase. So it is increasing in this area and also here. So increasing again, we're going to just be looking at, the x values. Okay, so I'm going to draw these vertical lines, and this is about x equals, it's not exactly on the -1, but just for now, for learning, let's just say that it is. And then we're going to put this one on the 1 as well. So this is x equals 1. And so the increasing, so again, we're reading our graph left to right. So what values make this graph go up? Negative infinity, it's going up. And then when it reaches -1, it starts and it turns down. And we also have, so we're going to do union, and then we're going to skip this area because this area, our graph is decreasing. It's going down. So then when x is 1, it turns and starts to increase again. So when x is 1, and then forever, so positive infinity, it increases. Okay, now the decreasing part is going to be the middle section here. So what x interval is making this graph decrease? We're going to say from -1 to 1. And again, we always read our graph from left to right, putting the smallest number first. In behavior, as x approaches negative infinity, as x becomes smaller in value, the output approaches. So as we go left on the graph is going down toward negative infinity. As x approaches positive infinity, as we go right on the graph, our output is increasing. It's going up toward positive infinity. Our exponential function, let's notice our asymptote here. I'm going to go ahead and write in y equals, and that looks like -4. So our domain, as we go left on the graph, our graph continues toward negative infinity. As we move right on our graph extends to positive infinity. The range, the least value, again, we're just looking at the y. It goes toward -4, but look, remember this asymptote is just a line that our graph approaches and never touches. So the range is -4, but is not included because it never touches the asymptote. And then it continues increasing forever. Our x-intercept is 2, 0 right here. Our y-intercept is 0, -3. As we go left to right to see what x values cause this graph to increase, all real numbers. So if your graph doesn't have a turn, it's either going to be all real numbers for increasing or all real numbers for decreasing. And this graph never decreases because we read from left to right, so it continues to grow. So we're going to put the null symbol. As the x values become negative, the output values, they get closer and closer to -4. So that's a little different. So take note of that. So as the graph extends to the left, my output is going toward -4. And then as the x values approach positive infinity, the output values are going up toward positive infinity. So the end behavior is all about the ends of our graph here, where they are headed. Okay, let's look at a few more